So today we move on from simplifying expressions to solving equations, where simplifying expressions is very important for solving equations as we get more difficult. So a couple of things we want to talk about first. The difference between an expression and an equation. Anytime we talk about an expression, we're talking about a bunch of terms linked by addition and subtraction. The key here, what you've been doing the past couple of days, is simplifying algebraic expressions with no equal sign. Okay, you can't solve anything that doesn't have an equal sign. Okay, you can only evaluate or simplify an expression, meaning you can plug a value in for x and get a single numerical value, but you cannot solve it. An equation is a statement that sets two algebraic expressions equal to each other, such as 3x plus 4 equals 2x minus 5. This is an equation because it has an equal sign and it sets one expression equal to the other expression. Okay, now expressions, like we said, we simplify or evaluate, whereas equations we can solve. So if we have an equation, what is the solution to an equation? Solution to an equation is the value of the variable that makes the equation true. Okay, so once we get the value for this variable, when we plug it in, the left side should equal the right side. So a couple of examples down here. Determine if x equals 4 is a solution to these three equations. Okay, what I do to determine if it's a solution or not is I take the value of the variable and I substitute it in for x. So I would kick out x, replace it with 4. Is 4 minus 5 equal to 6? That is a false statement, so it is not a solution. Okay? But example 2, when I look at 5x, that's the same as 5 times x. So 5 times 4 equals 20. Does 20 equal 20? Yes, that is a true statement. Therefore, x equals 4 is a solution to this equation. Then the last one, if I plug it in, 10/8 times 4, does that equal 5? 10 times 4, remember, put that over 1. 10 times 4 is 40. Over 8 times 1 is 8. Does that simplify to 5? Yes. Therefore, x equals 4 is a solution to this equation. Okay? Now here's the thing. Our goal is when we have an equation, can we find the value of the variable that makes it true? That means we're solving it. So first thing, when we solve equations, we use what we call inverse operations. Okay? Each operation we know of has an inverse operation. The inverse operation of addition is subtraction. The inverse operation of subtraction then is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. Okay? We will use these inverse operations to solve equations. So solving equations. Basically, we have one goal. And the one goal is to get the value or get the variable by itself by using inverse operations. Okay? So when we solve these equations, we look at how is 8 linked to x? Well, when we say this, we say x plus 8. So to get rid of 8, we use the inverse operation. Well, what's the inverse operation of addition? Subtraction, right? So I'm going to subtract 8 from this side. And then whatever I do to the right or to one side, I have to do to the other side. So I'm going to subtract 8 over here. Now, these should, whenever you undo addition or subtraction, what you're trying to get rid of should add up to 0. So we're left with x. This adds up to 0. 7 minus 8 is negative 1. And we are done. So over here, x minus 9 equals negative 12. Well, since we're linked by subtraction, the inverse operation is addition. So I add 9 to the left side. Then I go to the other side, I add 9 to the negative 12. So we get x equals, what is negative 12 plus 9 going to give me? Negative 3. Now what you notice is when I plug these values back in, is negative 1 plus 8 equal to 7? Yes, so we know that solution is good. Is negative 3 minus 9 equal to negative 12? Yes, therefore we know this solution is true. Now for example 3, it's not much harder. The only thing is how it's written. So now the variable expression is written on the right side. No different here. How do I get rid of the 5? Since it's linked by addition and positive, we're going to subtract it. That should add up to 0. Here we subtract 5. Now when I write my answer, I always want to write it with my variable first, x. And I'm going to write the equal sign. And what is 8 minus 5 going to give me? 3. And we are done. Okay. Now, number 4. To get rid of this 15, what do I have to do? Well, this is 15 plus x, but you have to look at the sign of the 15. Since it's positive, we're going to go ahead and subtract it. This should add up to 0. Does it? Yes. So whatever I do to the left side, I do to the right side. I bring down the x, and then 6 minus 15 is negative 9. Number 5, similar to number 3, I'm going to add the 10 to both sides. But when I write my answer, I'm going to go x equals 20 plus 10 is 30. And if you look, it's 30 minus 10 equal to 20. Yep, so you know your solution's correct. Now number 6, this one's a little different. Although these are linked by addition, if I just add, or if I subtract 7 here, negative 7 minus 7 is negative 14. I have to use the opposite of negative, which is plus. So now these add up to 0. And what did I do to the left side? I added 7. So I add 7 to the right side. X is equal to 22. So 1 through 6, we're using inverse operations of addition and subtraction. Now, 7. Whenever we solve multiplication, we want this to end up being equal to 1x. Okay, now we know 1x is equal to x. But whatever I get rid of linked by multiplication or division, when I get rid of it, the result should be 1. So what could I divide negative 6? Well, first off, negative 6 and x are linked by multiplication. What could I divide this by for that to be equal to x? Well, negative 6 divided by negative 6, that simplifies to give me 1x. Whatever I do to the left side, I do to the right side. Negative 42 divided by negative 6 gives me 7. I can plug this back in to see if it's right. Is negative 6 times negative 7 equal to 42? Yep, so I know my solution is correct. Now, number 8. A lot of students will get this wrong because they're used to dividing by what's on the left. But remember, I'm getting rid of what's linked to x. So negative 7 is linked to x by multiplication. So how do I get rid of it? I divide by negative 7. Divide by negative 7. Again, 1x written on the left. 63 divided by negative 7 is going to give you negative 9. Okay, number 9. X is linked to 9 here by division, right? So to undo division, we multiply. And if you think about it, if I multiply this side by 9, that would give me 9x over 9. And what does 9 divided by 9 simplify to? X. So these basically cancel each other out and leave me with x. Whatever I do to the left side, I do to the right side. Negative 8 times 9 is negative 72. And we are done. Now, number 10 is a little different. All right. We could divide both sides by 3/4, but dividing by 3/4 is a little complicated. So these type of problems, I make a two-step problem. The first thing I do is I always multiply by the denominator because that'll cancel out the 4's. So now I don't have a fraction. So I have 3x left. Equals, multiply the right side by 4, 12 times 4 is 48. Now, how do I get rid of 3? 3 is linked to x by multiplication, so I get rid of it by dividing, and x is equal to 16. All right, now the word problems. Try your best on these. These should be good, not too hard, but it says 5 less than a number k. And if you remember from all the work we did earlier, 5 less than a number k is written as k minus 5. You're 5 less than something, so you have to start with that something. So it's k minus 5. Anytime you see the word is tells you where to put the equal sign. So right there, I'm going to put the equal sign. And what does it equal? 12. Well, if I go to solve this, right, I add 5 to both sides, and k is equal to 17. Now, I know a majority of these equations you can probably just solve in your head, right? And what I mean by that is what times negative 6 would give me negative 42, negative 7. 15 plus what would give me 6? You know, you can basically figure these out mentally, right? But going through and showing the work as the equations get more difficult, showing your work becomes more important. Okay, number 12, the product. You have to remember, product means multiplication. So the product of 13 and negative 7 is negative 91. So 13 times negative 7 tells you to put that equal sign, equals negative 91. Is this a true or a false statement? It is a true statement. Okay. Now, 13, when we write this, 54 divided by 6. So 54 divided by 6 is equal to negative 9. Is this a true statement? No. This is a false statement, so it's not a solution. All right, number 14, 1/5 divided by 1/5 divided by a number n. Did I write this wrong? It should just say 1/5, sorry. 1/5 of a number n. So 1/5 of means multiplication, okay? And number n, so 1/5 of n is equal to negative 7. So again, how do we solve this? This is the one where we multiply by the denominator. Those eliminate. I'm left with 1n equals negative 35. And 1n is all we have to get to. So n is equal to negative 35. Okay, go ahead, try the homework. It should be pretty easy. And we'll see you at practice.